Today, we are going to discuss about Hadoop. What is Hadoop? Extensively. Okay. And as part of today's agenda, I've also written that we are going to discuss about file storage in HDFS, then basic commands in HDFS, write operation in HDFS, React awareness in HDFS, then read operation in HDFS, as well as feature and limitations of HDFS and all. Okay. Clear. Everything will discuss in depth. So let me start with the first point. Okay, file storage in HDFS. Let me scroll up. Fine, guys. So before moving into the file storage in HDFS, let's try to discuss a little bit, kind of recap. What are the things we have discussed in the last time? So generally, in the traditional system, there are two important problem we have seen, which was resolved by a beautiful ecosystem or the platform that is called Hadoop. Okay, so Hadoop is used to solve two major components that is exist in the traditional storage layer. Maybe RDBMS like Oracle, MySQL, or anything. One is for storage purpose. Another one is for processing part. Processing purpose. Let me scroll off. Yeah. So for storage purpose, it has given a beautiful component that is called as HDFS. HDFS, which we are going to see in depth. Okay. Similarly, for processing part, it is giving one of the beautiful engine. In short, we call it as MR. Then what is the full form of MR? That is map, reduce. And what is the full form of HDFS? Hadoop, distributed file system. Clear, guys? Any doubt so far? So this thing we have already discussed our last part of our last class, right? Any doubt? Any doubt so far? No doubt. Okay, that's great. Then in HDFS, so we understand. So HDFS is nothing but it's a kind of file system. It's not. So if someone asks, like you'll get a multiple question like this, is HDFS is a a kind of database, or it is a data warehouse, or it is a kind of file system, or it is a NoSQL DB. NoSQL DB means database. So which one is the correct answer? So it is a file system. Okay. Then we'll see how data is getting stored in HDFS. Okay. Now, coming to HDFS, think about, let me draw a diagram. Whenever you are giving the data, for example, you have the input data. Okay. I'll put, okay, let me put in this way. This is my input data set. Input.txt. Some data are present here. Okay, whenever you are giving to HDFS for storing that data. Now my question is, for example, this file system is containing the data having the size of 2 GB. So whenever this file will, or data will go and store in HDFS, how much memory it will occupy? Generally, how much memory it will occupy? Then simply you will think, okay, so I have a data file, I have a file, input file which contains 2 GB of data. Obviously, if I go and store into HDFS, so it will just occupy 2 GB of memory only, correct? So just 2 GB of memory. Just this part, let's say 2 GB of memory, right? 2 GB of memory. But guys, that's not the true. Okay, if I tell it will store 6 GB of memory, then how do you feel? You will go shout, what? Almost 3 times? Why, sir? Why, sir? That I'm going to explain as part of our agenda also. There is a concept called replication factor and all that we'll discuss one by one. Nothing to be worried. Okay, why? How 6 GB memory it will occupy if I will go and store a file size having 2 GB of data or containing 2 GB of data and all. Okay, fine. Let me share my PPT. Yeah, let me maximize it. Hadoop Distributed File System (HDFS) is a distributed file storage system designed to store and manage large amount of data across multiple machines. It is a core component of the Hadoop ecosystem, commonly used for big data processing and analytics. HDFS provides fault tolerance, scalability, and high throughput for handling vast data set. What do you mean by fault tolerance? That I will explain. Nothing to be worried. Okay. Then scalability means we can scale up either horizontal scalability or vertical scalability. That also we can see. Okay. High throughput means efficiency is more. Okay. Throughput means efficiency. Here is an overview of how file storage work in HDFS. Let's see how it works. There's a concept called, guys, block. I'll explain in my whiteboard. Just let me go through the document and all. HDFS breakdown file into fixed size block. Default is 128 MB, or I can say we can extend beyond 120 also. Let's say I'll make it 256 MB also. Each block is replicated across multiple machines in the cluster to ensure fault tolerance. Replication help in ensuring data availability even if some node got failed also. That is the work of fault tolerance. Anyway, I will explain. Now, NameNode and DataNode. The HDFC architecture is an HDFS architecture. Compares two main components, the NameNode and the DataNode. Okay, NameNode and the DataNode. The name node is responsible for managing for the file system metadata such as namespace, hierarchy, file permission and block location, everything. Now data node store the actual data block and report back to the name node about the health and availability of that block. Let me draw the diagram, you will explain what is talking about. Okay, let me come back to my whiteboard again. So generally, in my first class, not in the last class, my first class itself, I have already explained the entire Hadoop architecture. Okay, it follows the master-slave architecture. So let me just draw the diagram one more time. So it is kind of master-slave architecture. So this is my master node. Okay, this is my slave node. So for timing, it can be multiple slave. Let me draw only 3 slave. Okay. Like this, we have also multiple slave nodes are there, but I don't want to write all the things. Okay, for timing, let me draw only 3 slave. communicating is happening. Communication is happening. Communication is happening. Okay. This is name node. This is data node. This is data node. This is data node. Okay, so I can say this is basically, we can say what else, a name node or something like master node. Let me use a different color. Master, and this is slave. So let's say slave 1, slave 2, slave 2, sorry, slave 1 and slave 3. Now guys, generally, okay, let me draw. Whenever you want to interact with the Hadoop cluster, it's not like that directly you will come and store the data here. Data node means the data is actually set. Metadata means generally, what is master node? It contains the metadata information. Let me write down now. In the name node or master node, generally we store metadata information. Metadata information. But in the data node, actual data will be stored. Actual data will be stored. Actual data. Here also actual data. Actual data. So whenever I'm telling, I'm giving an input file and the data will go and store in HDFS. So HDFS means basically, I can say, you just think about this part, data node part only. And obviously the metadata information we are storing, but that is again a different concept altogether. When I will explain about Hive, I will come to that point. There's something called internal table and external table. So internal table storage location in on top of HDFS, but external table location is something else. That's why I'm making it optional. I'm not including this. Now I can say this dotted line mark, I can say this is HDFS only. So whatever the data you are storing in the data node, that is stored in HDFS only. But don't think that that does not mean metadata we are not storing. I told you that clarification you will get when we will enter into a Hive concept. Okay. Now, whenever I want to store the data, for example, this file data, is it like directly I will come and store here? No. There is no directly communication in between data node and you. Then what you will do? There is a edge node or a client node for that. Okay, I can say this is a kind of edge node. Think about this edge node. Okay, edge node or a client node, I can say. Client node, or sometimes you call it as edge node also. EDG edge node. Generally, what happens? The request will go from client node to name node. Let's say this is request. Then from name node, it will go to data node. Obviously, data node 1, data node 2, data node 3. Once it will complete the execution and all, response will come back from data node to name node, again from name node to client node or edge node. I can say this is response. Response. So once you get the response, then obviously your output will be displayed in the screen itself. You will get the output here. You are able to see the output in the screen itself. This is the output. Clear, guys? Any doubts so far? This is the typical architecture of a Hadoop ecosystem. Similarly, I also told you there's something called a secondary name node. Then where it exists? Yeah, it exists here. Let me drop each and everything in one single page. Then you will get much clarity. There is something called secondary name node. Secondary name. What is the work of that? Is used for backup purpose. Backup. PURPOSC. Yeah. It is used for backup purpose, guys. Clear. Any doubt so far? Any doubt so far? It is used for backup purpose. Okay. For example, uh, let me use a different color for communicate. What do you mean by backup purpose? Think about, or what is the other name of this? We call it as, this one is generally we call it as active name node. Active name node, in short I'm writing NN. This is called as passive name node. These are the important naming convention you should follow, because someone will ask what is passive name node. You should not shock like what is passive name node. First time I'm hearing. No, that means he's talking about the secondary name node. Okay, let me explain what is that. Guys, this active name node or the master node is the heart of the entire ecosystem, because it is controlling the communication between all the data node and all. Think about, there is some situation where the name node goes down, means got failed. And this is the central point of contact, means all the communication will happens through name node only. Because edge node or a client node directly cannot communicate with the data node. They cannot send the data directly to data node. They have to send the request to name node, then through name node the request and response will happens. Yes or no? Let's say, for example, this name node got failed. Then what will happen? Obviously, everything will be stopped. Then that means your job is not running. You have to wait. I mean, it's a waste of time. To avoid that situation, that's why we are always taking a backup name node or secondary name node. In case the active name node goes down, now the secondary name node will come up and act like a active name node, because it is got failed, right? Now secondary name node come and act like a active name node. If the passive name node becomes the active name node at that time, and it will take the responsibility of the active name node what was doing before. Okay, and how is taking backup or support? Like what are the metadata I'm storing here? Let me draw the diagram. This is my metadata information, right? Storing here. Every 3-second interval is taking a backup copy and storing here. So even though this name node goes down, there is no chance of losing the metadata information. Why? Because every 3-second interval, 3-second interval, not 3-minute interval, is taking a backup copy of the metadata and storing here. Again, taking a backup copy and storing here. That means every times whenever you see whatever data is available there, same data, set of data is available here in the secondary name node also. So whenever the name node goes down, this secondary name node will come into the picture. It will act as a active name node and it will do its own stuff. Clear, guys? Now the question is it like, sir? Now I'll explain the concept of fault tolerance. What is that fault tolerance? FAULT, fault tolerance. Okay, what is fault tolerance? No, sir. Sometimes before you told, sir, whenever the active name node goes down or failed, the secondary name node will come into the picture, which will act as an active node and take the responsibility of the active node, whatever it was doing before. Sir, whenever you are telling filling down, is fell down for temporary purpose or forever is like just filling down, then it will come up and all. Just tell me, whenever it's just got fail or it's got down, it will be like permanent, like throughout its life, or just 5 years, 10 years down the line, or maybe just for certain temporary purpose, like half an hour, 45 minutes, or 1 hour, then it will recover back, guys. It will be a temporary failure. It won't be a permanent failure. That means even though the active name node goes down, there may be a chance that after half an hour, 45 minutes, or 1 hour, it will recover back from failed state to active state. Then at that time, what happens? Again, passive name node or second name node go before its previous state and act as a passive name node only. Because now my active name node becomes off. It's up and running. It is taking care of its own responsibility. Now it's not rely on second hand node. That process is called fault tolerance. So if you write the definition, fault tolerance is nothing but the process of recovering back, the process of recovering back from failed status to active status, active mode or active status, whatever you call, active mode or active status is called as fault tolerance. Guys, clear? Any doubt? That means it is one of the beautiful concept of the Hadoop ecosystem, or I can say HDFS and all. Even though any data node goes down, name node goes down, automatically due to its internal structure, they have designed the structure in such a way that automatically it will recover back from the failed status or stage, STAG, failed stage to active mode or active status. That process is called fault tolerance. I hope now you got 100% clarity. Now you tell me. Sir, you told metadata information was stored here. Fine. You told actual data stored here. Fantastic. Now could you please give me some internal implementation of the Hadoop? Sorry, HDFS. How it is generally stored and all. Okay. Let me come. Give an example through which I can explain about the replication factor and all. Okay. Before that, let me see anything I have. File storage, basic commands. Okay, right operation react awareness in Hadoop. Okay, that will come in the react awareness. Let it be. Let me complete first the file storage is completed anyhow. File storage is completed. Now let's talk about basic command in HDFS. Okay. Okay. What are the basic commands are present in HDFS that we are going to discuss here? Guys, clear? Any doubt so far till this point? Any doubt? Please let me know. Okay. Coming to basic command, let me go one by one. The first one is something like ls. What ls will do? For example, you have opened a folder, or let's say anything. Let's say you are like D drive or something. Then inside that some folder is there. You have opened that. You want to see list of all the file directory folder that is present in that location. Then for that you just have to run ls. Ls means list of all the subfolder. List of all files, folders, or directory generally whatever it folders it will display. It will display. Similarly, another command is called mkdir. What is mkdir? The name itself is telling mk, make, make, make. Okay, dir stands for directory, ractory. So how to create a directory? Basically, directory is nothing but a kind of a folder structure. Think about the folder structure in Windows. Okay, how to create a directory? That is mkdir. You create mkdir, then give some name. Let's say temp, tmp, or something. Then that is a folder will be created with a name called temp. Are you getting my point? Any doubts? Any doubts? Now, I have created a folder. Fantastic. For example, I have created a folder name called, let's say, temp. This is a folder. Think about it. This is a folder. Now, inside this folder, I am to create a file. Let's say empty file I have to create. That empty file name is called, let's say, input.txt. Input.txt. dot txt. Nothing is written, just empty file. Then for that, I have to run a command called touchz. Touch touchz. If I'll run touchz, then file name, let's say, example, let's say, let me write the example, something like this. touchz, let's say, input dot txt. Then in the same location, like wherever you are running the command, right? Because this is a Linux Unix command, right? Then in the inside the temp directory only, there will be file will be created with the name input.txt with the empty. I mean, nothing. It does not contain anything because I'm not getting any data into that input.txt file. Clear, guys? Clear. Now, for example, you open the file. Okay, let me scroll it off. Okay, you open a file like input.txt. You open the file, then you write something. Okay, like for example, you open the file and you have written, let's say, I uh, I am a what Hadoop student, and then you save it and close the file. Now, whatever you have written, I don't know because initially you have created an empty file. You told me, but you have latter point of time you have written something that I don't know. But I have to read whatever you have written in that file. Then to read that, I have to write a command called cat. So what is the like example? I can say example is, so I have to run obviously cat command and then file name cat input dot txt. If you run this command, then obviously whatever text or whatever things you have written inside that, it will be displayed here as part of the output. So as an output, what I will get, I am a Hadoop student. Clear, guys? Any doubts so far? Any doubts so far? Similarly, let me tell you just last, because like this, lot of other commands are there. I'm just highlighting some important commands, okay? Because we cannot cover each and everything, right? It's not required also, right? For example, think about, let's say there is a directory called uh, let's say there is a directory called Hadoop. Okay, Hadoop is a directory. Here there is a file present called abc.txt. Now you want to move this file abc.txt, okay, from Hadoop directory to, I mean basically you have to copy from Hadoop directory to this directory, temp directory. Are you getting a point? This temp directory. This file you want to convert to this temp directory. So obviously now whenever you will see the ls command in temp directory, you will see two different files, input.txt file and abc.txt file. So how to copy? For that I can write copy. The command is from local. Copy from local means think about this is your local environment, local directory. And from there you are copying from local, then you have to keep source directory, and destination directory. Okay, that means if I write the example, it will be copy from local. Source directory is Hadoop. I mean, Hadoop means obviously it will be something like this: D drive, let's say Hadoop and all, right? Two, let's say this is again D drive. What temp, temp, okay, temp directory. Then a file whatever present inside this, and obviously you have to write. Okay, sorry, copy from local. File name you have to write which file you want to do. abc.txt, right? Txt. Then your source path and destination path. Getting my point? If you write, then a file will be copied from source location to another location. Clear, guys? Any doubts so far? Any doubts so far till this point? Okay. Let me go to the next one. That is write operation. Okay. First we'll talk about the write, or first I'll talk about the read operation. Better. Let me see. Read operation is or write operation. Write operation is a bit. Okay, let me first complete the read operation because read is very easy, right? Obviously, I mean before reading you have to write. That is true. So let me first complete the read operation. It's a kind of sequential manner. Okay, read operation. Sorry. Then I'll talk about the write operation. Because this is easy. I call this not changing. Yeah. Let's talk about the read operation first. Read operation in HDFS. Okay, for that, let me share my PPT and I will explain you in depth. Guys, please point any doubt, please let me know. Okay, I got a message from the management. Just 1 minute, let me just reply. Okay, fine. Yeah. See how the read operation is happening. So I was talking about the edge node or a client node. This is nothing but the same. Let me maximize it. Okay, edge node or a client node. Okay, so here my name node is present. You can see whatever the request and response operation is happening, communication is happening, nothing is happening directly. I mean, as a edge node or a client node, you cannot directly connect with the data node. All the communication is happening through name node only. You can see the number also I have given for your better understanding. First, you have to establish a connection like distributed platform, because we are also working on distributed platform, right? HDFS itself is a distributed file system because the name itself is telling distributed Hadoop distributed file system. So this is nothing but HDFS, Hadoop distributed file system. You open it, means make the established connection. Then second, number two, metadata request to get block location. So where is my block location resides? What is the block and all? Everything I will explain. Nothing to be worried. Okay. What is that block location and all that is present in the name node only? Then it will pick the block location from the name node. Then number third, metadata flow. So we come to the distributed system. Then come to the FS file system data input stream. Then by using data input stream, my request will go to FS data input stream. Then from there, it will go to each and every data node based upon the metadata information that is picked from the name node itself. For example, a name node will tell, man, in the DataNode 1 and DataNode 2, I have the empty spaces. Please go ahead. Sorry, I'm doing the read operation, not write operation. Sorry. So whatever request I'm giving, the request later response is present in the DataNode 1 and DataNode 2. So it will give as a metadata flow saying that, hey, your answer is present in DataNode 1 and DataNode 2. Go and look for DataNode and DataNode 2. Don't look for other DataNode, because think in the real time, not only we have only 3 DataNodes are present, we have more than 10 DataNode, 12 DataNode, 16 DataNode, 32 DataNode are now. Do you think that it will go each and every DataNode and try to search what is present? No, right? So, for example, you are giving select star from employee details where a salary greater than or equal to 50,000. Do you think that it will go and search each and every data node where is that employee table present? No, right? So that information who will give? The information name node will give, saying that, hey, the employee table present in these two data node. So you please go ahead and search in this data node only. No need to source in other data node. Clear, guys? Any doubts so far? Then once your operation completed, response will go back from data node to again FS data input stream like fifth and sixth. Then again from here it will go to seventh and close it. Make it close. That's all. Clear, guys? Any doubts so far? So from here we learn a new thing's gonna block. So what is block and all? Let me explain. Okay, let me go back to my whiteboard and explain what it is block and all. Explain. Clear? You can see. Whenever I'm giving the request, metadata request to get a block location. I'm giving the request. Tell me the block location where my information getting stored. Now my name node is giving me the response metadata flow, saying that okay, your information is present in the data node 1 and data node 2. That's why there is a communication between data node 1 and data node 2 by FS data input stream. You see, there is no point to data node 3. Why? Because it's clearly telling it's present in data node 1 and 2. Why you want to look for data node 3, 4 and all? It's a waste of time. Getting my point? Then it makes our execution or flow very much. Same things or not? Right? I was explaining the same things, right? Whenever you are giving a request saying that select star from EMP where salary greater than equal to 50,000, first of all, it will try to predict, try to find out where the employee related information are present in which data node. That it will ask to name node. Could you please give me the data node location and all? Then as part of the response, metadata will give the metadata flow saying that okay, your employee related information are present maybe data node 1 or 2 or maybe only 3, not in 1 and 2 or maybe only in 2, not 1 and 3 and all. Then you will go ahead and make the established connection with that particular data node and try to give the request, and the request related information will get, and it will passes to metadata. Again from metadata it will come to your screen and display the screen as part of the output. Getting my point, guys? That's how the communication happens. This is a read operation. Similarly, let's go for write operation. For example, I want to write something because you have inserted this data before. That's why you are able to read like select star from EMP. Now my question is how I will write that employee related information. Writing operation let's discuss. Okay, that is very interesting. Okay, so let's go for now write operation. Where's my marker? Yeah, write operation. Okay, write operation in HDFS. Okay, write operation in HDFS. Again, let's go back to my PPT and I will explain there itself. Are similar to read operation only, little bit different. That difference I'll tell you. See, here, same HDFS client. It is trying to establish the connection with fast HDFS distributed file system. Then it is going to a request, giving a request to the name node, right? What name node is telling is just giving. Okay, once they give the request to the name node, again they are giving the request to the FS data output stream. They are FS data input stream. Input means I am to read it. Output means obviously output from where? From here. From here to outside means I want to write it. That's why FS data output stream. You can say DFS output stream data. Then it's asking whatever the data you want to write. For example, let's say simply I am a Hadoop student. So I is a word, am is a word, a Hadoop student. It will store in the queue, right? As per the queue. Okay, you might have heard about the stack and queue data structure, right? There is 1 minute. I'm getting it all. Yes, tell me. Now we can see. So once my data will be stored in the queue, Once my data will be stored in the queue, then I am giving to data node 1 or 2 or 3, that will be decided by my name node only, because my name node will tell which data node having the empty space. Getting my point? Because whenever I'm giving the request as a metadata flow, my name node will tell me, let's say in data node 2, I have the empty space, but data node 1 and data node 3 are filled up. If there is no empty space, you cannot write, you cannot store any data. Then only I can go ahead and give the request for writing operation, that is FS data output stream, and whatever things I want to write, exactly the data that I will store in the acknowledged queue only, right? Data queue only. From data queue, it will go to the data node. Once it will be stored, then I will get an acknowledged queue saying that yes, I have successfully done the right operation. Then my response will go back to the HDFS client saying that yes, right operation done. You can see the last one is 11. So the first one is a distributed file system. Second one is asking for tell me which data node having the empty space. Then based upon that, I'm giving the request to the DFS, FS data output stream. Then fourth one, I'm storing the data in the data queue. Then by using the data streamer, also I'm trying to connect to the name node. I'm trying to find out the same things. Then coming to data node 6. What is 6? 5, 4, 6 missing or what? This is 6 actually. After 5, this is 6. Okay. Then 7, writing in the package. Then it will be all the data node will be in sync. For example, I will tell you the replication factor, right? So I will create 3 different copy of that particular data. That will be maybe one copy will be stored in here, another copy will be stored here, third copy will be stored here. All data node will be in sync. So that's why you can see 888. Okay, once done, obviously I'll acknowledge it. Okay, it's done. Okay, then response I'll check. Okay, I have done from data node 3, then 2, then 1 and all. Then I'm sending the acknowledgement. Sending acknowledgement packet back to my FS data output streamer. Then from there it will go to the edge node or the client node for the session close itself. Session close means what are the connection or the established connection I have done before start of the writing operation. Clear, guys? Any doubts so far? Any doubts so far? Okay. Sometimes before I was talking about how I am storing a file whenever I am giving to HDFS and all. But here the cinema is not ended actually. The extension version of this cinema actually I am explaining here. Okay. Think about the same file. Okay. Let me take the same file, same example so that you can correlate. Same, that is a input file called input.txt having size 5112 MB of data, which contains huge amount of data. Fantastic. Now I have HDFS. Think about this is a data node 1. Let's say this is data node 2. Let's say this is data node 3. I'm writing here data node 3. In short, I'm writing data node 1, data node 2, data node 3. Okay. So as you know, we have different rack. And inside rack, I'm storing in the block size wise. Clear, guys? Fine. Now, as I told you, my default block size. Why is not changing? is equal to 128 MB only. That means how many blocks will be created? We have decided 5112 divided by 128. There is nothing but 4 blocks. 4 blocks has been created. Getting my point? 4 blocks. 4 blocks has been created. Fine. Now the question arises. I've also asked the question in the start of my class today only. For example, this block file having 512 MB data. Whenever I will store into DataNode, is it like only 512 MB memory it will occupy or it will be something else? We have seen it was taking the file size into 3 times. That is the memory it will occupy in HDFS. Why? There is a concept called replication factor. Let me explain, then I'll come back to here. Okay, there is something called replication factor. What do you mean by replication factor? And why we use that? Everything I'll explain as part of our journey. The replication factor is nothing but kind of number of copy that I'm creating for a different file. For example, think about I have a file called abc.txt. Whenever I will store in HDFS, if I will store only one copy of the file, think that in the DataNode 1, let's say that DataNode 1 got corrupted. What will happen? There is a chance of losing all the data that is stored in this file. That's why I'm creating 3 different copies. That depends on the replication factor. So by default, the replication factor value is equal to 3. In Hadoop, they are maintaining 3. I mean, you can increase or decrease. If you make 5, it will create 5 different copies. If you make it 2, it will create 2 different copies. That's why by default scientists they have decided to take each number 3. Why? Because even though one copy got deleted, another 2 copy will be there with them. So there is no chance of data loss. Getting my point? That is called replication factor. And in Hadoop, 3 is the default. Three is the default replication factor altogether. Okay, now come back. You understand? Now come back. Okay, sometimes before I was talking about 4 different blocks. Let's say that 4 different block name I'm giving just to make you understand and to make it simple. Okay. For example, that 4 different block I'm giving, I'm drawing here. Let's say that first block name is, let's say, block A. Another block name is called block B. Third block name is called block C. And the fourth block name is called block D. Getting my point, guys? Not to confuse you, I'm giving you a specific name. It's nothing but 4 different blocks that I have created from the input file. This is input.txt, right? I hope you are clear. Input.txt. And I have 4 different blocks because my file size is equal to 512, 512 MB. And as we know, my block size, default block size is equal to 12. So 512 divided by 128 is equal to 4 blocks. So 4 blocks will be created. I am giving different name to make you understand in easy way. Okay. Now what happens? As you know, the replication factor is equal to 3. That means for each block, 3 type of replica. I mean 3 copy of replica will be created. So for example, let me draw that one also. Okay. For A, I am creating 1 copy, another copy, and obviously including this one copy is there, another 2 copy I am creating. So total will be 3. Correct? So now another 2 copy, another 2 copy. Now say for A, this is also A, this is A, this is B, this is B, this is C, this is C, this is D, this is D. Right? Now tell me, guys, I'll prove it. How is it 3 times coming? Now this is the entire input test or not? Like A plus B plus C plus D. How much it was? 512, right? Which is nothing but my input file size, 512 MB. If I will add it up, sum it up, then again it is A, B, C, D, again 512 MB. If I will add it up, again 5112 MB. Now, if I sum it up all the things, I mean, first copy it occupy 512 MB of memory, second copy occupy 512 MB memory, third copy occupy 512 MB memory. If I will add it up, then what will happen? It will be three times of input file memory or not. Input file memory or not? Tell me guys. Yes or no? Yes or no? That is the reason why, based upon the replication factor. Now, in this case, my replication factor is 3. That's why it is 3 times. For example, you increase the replication factor from 3 to 5, then it will become 5 times. If you increase the replication factor from 3 to 7, then it will become 7 times, 5 times. Okay. So it depends what is the 3 or 5 or 7. Nothing about the replication factor that is decided by you in the Hadoop infrastructure design only. Now you tell me. Now let's stick with the 3. Now tell me, if I create block A, block B, block C and all, tell me. So for example, here my block A present. These are some small things are block, and rack is nothing but, think about, this is a one rack. Think about, let me write down the different color. Rack 1, rack 2, rack 3. This is rack 1, rack 2, rack 3. This is rack 1, rack 2, rack 3. Now guys, tell me, it's very very interesting. Try to understand. My condition is I should not keep the same block under the same data node and same rack. Why? I'll tell you. For example, okay, let me first go for the positive way, then I'll explain why not. So I'm storing rack A. So I cannot store another two copy of A under the same rack. That is AA. I cannot write. I have to store into different rack. Can I store in different rack like R2? I can store, but it's highly recommended not to store. I mean, I can store. For example, I can store here also A. Okay, let me write down A here. Okay, A here. Now, already two copy I have stored. Now, is it like another copy also I will store in R3? No. Do not store all the copy of the same block in the same data node. Why? Because in case, think about, I am storing A here. In case the entire data node goes down, data node 1 goes down, then I will lose all the data. So it is highly recommended to store another copy into separate data node, that may be rack 1 or rack R1 or R2 or R3. But again, you can ask me, sir, if both the data node goes down, then I will also lose the data. That is the reason why it is highly recommended. Always try to keep one copy of the block in the same rack, that in the same data node. Keep another copy, the last copy I can say, let's say here A. Now you see, this is the proper orientation. So I'm talking about only block A. So block A I'm storing here in data node 1, data node 2, data node 3. So it's not like that all the 3 data nodes will be fail all at a time. No. That scenario is worst to worst scenario. Never happens. And in case data node 1 goes down, I have another 2 copy. In case data node 1 and data node 2 goes down, still I have another copy. I don't have a chance to lose the data. Are you getting my point? Similarly, let's say block. Is it like, can I store my block B here? Happily you can store. Highly recommended not to store in the same data node. I can store block B here, and here block B, another B. Here also, not only I am distributing among the data node, but also I am distributing the rack also, because here rack 1 plays the same role as this one. So as I have stored block B in rack 2, I am trying not to store the same block B in the R2. That's why I am storing in the R3 here and here R1. Similarly, here I'm storing in A in R1. Here I'm storing in R3. Anyhow, I'm storing in R1. That's not a big deal, but better if you store in R2 than here in R1, here in R2, here in R3. That's it. Exactly, I can get excellent distribution format. Now, these metadata information you have to store in the name node only. In the name node only. So for the name node, what will store? So for example, I will ask, tell me the position or the address location of a block A. Then it will give me the answer like this. It will be first data node will come. Data node 1, rack 1. See, that's how it is got stored. Comma. Data node 2, rack 1. Because rack 1 here. Then comma. Data node 3, rack 3. Similarly, could you please give me the location for, I'm just showing the example for 2, the rest of the things you can imagine. Okay. Location for block B, yes. Then block B will come. Now tell me, location of block B, here block B storing, right? So data node 1, React 2. Then data node 2, what is the rack? React 3. Then data node 3, React 1. I can say this is an excellent distribution. Why? Because I am storing in 3 different racks. See, my combination, how beautifully I have designed, I am storing, I am utilizing all the rack. Rack 1, rack 2, and rack 3. The two different data node also. Even though here I'm using different data node, no doubt, data node 1, data node 2, and data node 3, still in data rack 1, I am storing 2 different copies. So better, it's highly recommended if I change something, let's say 2, or maybe this is 2. So then it will be different rack and different data node altogether. Then I can say there is no chance of data loss. Even though any of the rack got failed, any of the data node got failed, I will be having always one single copy with me. That is the reason why it's not recommended to keep all the block, same copy of the block in the same data node or the same rack and all. It's highly recommended to keep in the distributed manner. Now you understand what is the meaning of distribution. In the first class I told you, distributed means scatter. This is called distribution because I am not storing the data as an isolated manner that too inside a single data node. Throughout across my globe, wherever my data node is present, I am taking the replication of that particular block and storing across it. Are you getting my point? Now, this address will be stored in the metadata only that to name node or master name node. So whenever as a edge node or client node you are giving the request, it will give as a meta flow. Okay, what you are looking for? Sir, I'm looking for a location B. Okay, you are looking for location B. Where is that? Where is that? Yeah, location B. Okay, then you go for data node 1, React 2. Go to data node 2, look for React 3, and go to data node 3, React 1. Guys, here also cinema not completed. As I told you, we are also storing with the block size or block number. That block number will come into here. Let me complete that one also in single shot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Similarly, can I number the last one? Yes, just 1 minute, guys. My mouse is sometimes not working. Just 1 minute. Yeah. Sometimes it's taking time. Okay, fine. Now, similarly, here I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Now tell me, it's the beauty. Now, when I'm telling DataNode 1, React 1, for example, let's say I'm looking for location A. And my metadata told that, my name node told that, okay, go for DataNode 1, React 1. So React 1 having 5 different block. Do you think that I will search for 5 different blocks? Then how optimized will be happens? No. Because for example, here present last, then I have to go 1, not present, okay, go to 2, not present, go to 3, not present, go to 4, not present, go to 5. Oh, I got here. No. Particularly I tell where is present, you tell me, then the location I have to give the block number, okay. Rack 1, block number 1. In DataNode 2, rack 2, block number 2. That's 2 here, A present, right? Then DataNode 3, rack 3, block number 16. 16, right? Yeah, 16. Now, B present in DataNode 1, rack 2, that to block size 7. Fantastic. You can write 7 or B7, that is block size. Okay. DN2, R3, that is 13. 13. Okay. Then DN3, R1, that is 6. 1, 2, 3, 4. Yeah, 6. 6. Getting my point, guys? If I will give this information now, guys, think, for example, I'll tell, okay, I'm looking for location B. If you tell me, go for, let's say, DataNode 1, React 2, 7. DataNode 1, React 2, then 7, 7. Immediately I will navigate here. I no need to traverse from 1, 2, 3, 4, 5, 6, something like that. No need of wasting time. That is the reason why it is a very, very efficient. 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 I was talking right. It will result two different problem statement. One is storage, one is processing. I was telling how it was not efficient in the traditional database like Oracle and MySQL because taking a lot of time for searching operation. Now you can understand why searching operation is faster whenever we are using any file system. Because I'm not traversing each and every block one by one. Directly I'm navigating based upon the location or I can say position that is stored in the metadata information as part of the metadata information. That too in the name node only. Name node only. Guys, clear. I hope you got a clear cut understanding, a solid concrete of the base, like how it works, guys. Frankly speaking, such type of explanation you will not get anywhere. I mean, in a textbook or anywhere. Okay, I mean, you can get theoretical things, picture and all, but such type of explanation you will not get. In depth, bit by bit, I'm explaining each and everything. Why? Because I have worked on this core concept. If you will not get a chance to work, guys, frankly speaking, it's not possible to know all this in details. Very, very difficult. And if you explain like this, I'm telling you, the interviewer will be flat. Interviewer will be flat. And he will tell, okay, got selected, done. Even if with those many things also, he may or may not, she may does not know. Even unless he work on the core on-premises HDFS file system. Because nowadays people have started working cloud environment and all. Let's say in Amazon, people are using S3, Amazon S3. In GCP and Azure also similar stuff. But this is the core HDFS, Hadoop distributed file system. I have started my career like 7 years back. Then at that time, I had explored and I have worked on that. That's the reason why still, after 7 years also, I'm able to recall and trying to explain in the same manner without skipping or without omitting a single point also. Clear, guys? Any doubt so far, please ask. Please utilize this time. It's up to yours time. Yeah? Fine. Now, let me officially tick mark, then go to the last point, that is features and limitation of HDFS. But yeah, before that, ask me, and if you want, just 2-3 minutes break also you can take this. I'm continuously speaking. I also need a small break. Okay. My mouse is getting hang. It's not working. I don't know why. Okay. Now, features of HDFS. What are the different features are there? You can say cost effective. Second one is a large data set. Third one is a replication factor. Fourth one is fault tolerance, high availability, then scalability, data integrity, high throughput, data locality. These are the 8 to 9 important features that are related to HDFS. Let's try to see and try to understand each and every features. Cost effective. What do you mean by cost effective? To design HDFS, you don't have to spend much amount of money. Okay, just commodity hardware is enough. I mean, it's kind of lower grade, I can say, a computer, not higher version like GPU and more memory of CPU and all. Then you can design your HDFS infrastructure also, cost effective, very less cost. Second one, large data set. As you have seen, we can add as many number of data node to store the data, kind of horizontal scalability, vertical scalability we can do to store large amount of data set. That's why we moved to HDFS, right? To store the big data. That was the problem with the traditional database, because by using traditional database, you can store up to limit, let's say 1 TB of data. Now what's about more than 1 TB, like 10 TB, 100 TB and all, that you can store in HDFS and all. So large set of data you can store in HDFS. Now, third one, replication factor. Due to replication factor, it avoid us data losing and all. We have seen extensively how it is distributed among all the different data node, RAG, block and all. Okay, and by default the replication factor is 3 in Hadoop. We can increase and decrease based upon our requirement. Generally, nobody prefer to decrease. Why? Because for example, decrease means what? You cannot tell make a replication factor 1, right? Means 1 is what? If that will be deleted means gone. So at least 2. 2 means if 1 is deleted, then another copy is there. But think about, suppose in bad situation 2 copy will be deleted. Then it will be you will lose all the data, right? So that's why we have taken the best number as 3. Even though 2 copy will be deleted, then another copy will be there. Now you may ask me, sir, if 3 copy will be deleted, if you think like that, then there is no chance of replication factor. If you make it 10 also, you think that, sir, if 10 copy will be deleted, then do you think that you will create 1,000 copy? No, because as you create 1,000 copy, whatever the input data set you are giving, into 1,000 times it will occupy the memory. Guys, are you getting my point? It's the waste of time, waste of memory, it's a deficit itself. That's why for convenient point of view, they have set the base value as 3. But as a Hadoop infrastructure design or a Hadoop admin, if they want to increase, they can increase also. Fine. Now, fault tolerance. What is fault tolerance? We have seen extensively. For example, my name node goes down. Then automatically it will recover back. Or maybe my data node goes down. Automatically it will recover back from the failed state to active mode. That process is called fault tolerance. This is the default feature of the HDFS. That's why it is very much popular and very much efficient and all. Then high availability. What do you mean by availability? As I told you, for example, I have multiple data nodes are there. If one data node goes down, whatever the task you have assigned to that data node, if that goes down, same replica of the task will be created and assigned to another data node which is readily available, which will take care of the execution of that task. It's not like that one data node goes down means you have to stop, you have to wait till that data node come off to active status. No. Highly available, always available, 24/7. Now, scalability. As I told you, we can go for either horizontal scalable or vertical scalable to store our huge amount of data set. So that is also possible by using scalability. Now, data integrity. So there is a communication between the name node and data node. And there will always data integrity means it is in the sync throughout each and every data node. For example, I am doing a write operation. When I'm doing the write operation, as I'm implementing the replication factor, I'm creating different copy. So all the data node will be communicating each other, saying that the data that I'm trying to write, that will be in sync and perfectly it will obey the replication factor. That many number of copy has been created and stored into different rack, that to different data node also. High throughput efficiency. How? As I told you, whatever the data I'm storing, its corresponding data node location, rack location, and a block number are getting stored in the name node itself. So whenever I'm doing any searching operation, directly my pointer will navigate to that block location by taking the location from the name node itself. I know it to traverse one by one block serial manner, I can say. I'll directly jump and hit to that block to get my output. Now, data locality. So as you know, obviously it is in sync and data is present locally. Means I can play around like from local file system I can move to HDFS, from HDFS I can move like copy from local, copy to local, and I can bring back the data from a data node to my edge node to see the output, the display the output. That's also possible. Now, come to the next. The main problem with Hadoop is that it's not suitable for small data. Hadoop lacks the ability to support the random reading of small due to its high capacity design. Small files are smaller than the HDFS block size, that is 120 MB. If you are storing this huge number of small files, HDFS cannot handle this lot of small files. As HDFS was designed to work with a smaller number of large files for storing large data set rather than storing a large number of small files. What is telling guys? For example, think your file. We know our block size is 120 MB, right? Think about I have a file whose size is less than 120 MB. That means your file is happily can be stored inside one block only. That too, other I can say rest of the memory will be wasted, right? Because you cannot store other details in the same block. Think about let's say your file size is only 20 MB. So 20 MB can be happily stored inside 128. Now 100 MB of memory wasted. You cannot use by other file or other data, right? There is a lot of many small file, then the name node will be overloaded since it is for namespace of the deepest location only. Now you can see file and block. Yeah, that I have already explained in a whiteboard, just in a different diagram I am explaining here. Think about, let's say I have a 400 MB of input file and I know each block size having 128. Then total how many blocks required to store 400 MB? 400 divided by 128. So it will come 4 different blocks. So each having 128, 128, 128, then 16. Because if you add it off, it will become 400. So you add 400 minus 128, minus 128, 1 minus 128, then it will become 16. That's why I've given the plus symbol. So if you add all these 4, it will become 400. Now, fantastic. Now, what will happen after that? Let's understand. You can see it's written also 120 MB, MB, MB is equal to 400 MB. Means 4 blocks are created, each having 120 MB except the last one, because last contains only 16 MB of data. Hadoop does not know or it does not care about what data is stored in this block. So it considers the final file block as a partial record as it does not have any idea regarding it. In the Linux file system, the size of the file block is about 4 KB, which is very much less than the default size of the block of the Hadoop file system also. As we all know, Hadoop is mainly configured for storing the large data which is in petabyte. This is what makes Hadoop file system different from other file systems, as it can be scaled, horizontal scale or vertical scale. Nowadays, a file block of 120 MB, they are generally increasing to 256 MB also and considering Hadoop. Because initial point of time, they are reaching the block size as 120 MB. I have seen as part of the optimization, Hadoop admin team people, they increase from 120 to 256 MB also, so that large file can be stored into a single block. Clear guys? Any doubts so far? Now replication factor. Anyhow, I mean I have already completed. No need to spend more time. I mean if you want, you can just go through it. I'm just keeping for 2 minutes. But same things I have explained. Okay. So by default, the replication factor is 3. So if your it's creating 4 different blocks, then total it will be 4 into 3 is equal to totally 12 different blocks will be created. Right? I also done the same things. So for each 3 blocks, right? So 3 into 4 is equal to total 12 different blocks. And where this replication factor entries will be there, like as I told you, this is taken care by the Hadoop admin people. Last class I have told you some environmental file like Hadoop HDFS-site.xml. In this file only, we are maintaining this value, replication factor value of the HDFS. So there, if you open that file, you will see replication factor mentioned is equal to 3. If you increase to 5 and save it, now your replication factor become 5. If you open and save to change to 7, now your replication factor becomes 7. But generally, frankly speaking, in the industry, you will not get that chance to do that because that is taking care of the admin people which is designing or which involved in the infrastructure design and all, not a developer like you. Okay. Okay, let's go through some poll question altogether. Now, guys, tell me, you have to just write down the answer, like option, either A or B or C is the correct answer. What is a key characteristics of distributed system? Option A, centralized data storage. Option B, low fault tolerance. Option C, limited scalability. Option D, components working on different machines. So which option you are thinking is the correct option? Could you please tell me? Please ping on the chat box.